Hello student, today we will do question number 6 from miscellaneous exercise on chapter 7 NCERT Math Books class 12. So without a further ado, let's get started. To find integration of this, so we will integrate this by partial fraction method. So for this we will suppose let 5x x plus 1 x square plus 9 is equal to a by x plus 1 plus b x plus c by x square plus 9. This. Now we'll take LCM. X plus 1 x square plus 9. Here will be a into x square plus 9 plus x plus 1 into b x plus c. If you multiply this, then ax square plus a9 x square plus 9a plus bx square plus cx plus bx plus c divided by x plus 1 x square plus 9. This is. Now we will take common x square, then it will be a plus b x square plus x. If we take common, then b plus c x plus 9a plus c divided by x plus 1 x square plus 9. Now we'll compare coefficient from here. From this, if we compare coefficient, so there is no x square, so a plus b is equal to 0, number 1. B plus c is equal to 5, number 2. 9a plus c 9a plus c is equal to 0. This is 3. Now adding equation, now we have to find value of a, b and c. So how will you find? adding 1 and 3, we get, if you 1 and 3 will add, then it will be 10a plus b plus c equal to 0. Now we will put value of b plus c from equation 2. So 10a plus b plus c is 5 equal to 0, means a equal to minus 5 by 10, means minus 1 by 2. So a equal to this. So b, if you put value of a in equation 1, so b will be 1 by 2. Now we have to find, if we put b value in 2, so we will get b value is 1 by 2 plus c equal to 5. So c equal to 5 minus 1 by 2, means 9 by 2. So we have got value of all. A equal to minus 1 by 2, b equal to 1 by 2, c equal to 9 by 2. Now we will put here in equation this. Integration of 5x dx divided by x plus 1 x square plus 9 is equal to then integration of a x plus 1 dx plus integration of bx plus c by 9 dx. Bx plus c and x square plus 9 dx. That's it. Now we will put value. A equal to, we will put a equal to 1 by 2 minus 1 by 2. So take out minus 1 by 2 outside. This is 1 by x plus 1 dx plus bx. B value is b, we can write this that way. Here we can write this a by x plus 1 dx plus this, which can separate this, can write bx by x square plus 9 dx and plus c by x square plus 9 dx. this we can separately. Now put value of a b is here. B value is 1 by 2, so we'll write 1 by 2 outside. 1 by 2 x by x square plus 9 plus c value is 9 by 2, so 9 by 2 into x square by x square, here dx also, x square plus 9 dx. Now we will integrate this separately. We suppose this is I1, this is I2, and this is I3. We will separately integrate this, and then in the last we will add this. So I1 is equal to minus 1 by 2 integration 1 by x plus 1 dx. So integration of this will be minus 1 by 2 log x plus 1 plus c. This is I1. I1 is equal to, now I2. I2 is equal to 9 by 2 x dx. X dx by x square plus 9. This, for this integration we will let x square plus 9 is equal to t. If we differentiate both sides, then 2x dx is equal to dt. So x dx is equal to half dt. Now we'll put here 9 by x dx. X dx is equal to half dt, so half will bring this side. So 1 by this is dt by x square t we are suppose. So this will be 9 by 4 log t. Log t we had suppose x square plus 9 plus c. This is I2. Now I3 we will find. Is equal to 9 by 2 I So 1 by 2. I2 1 by 2. This is 1. In I2 this is 1. 1. So this is 1. 1 by 2. Here 1. So this will be 1 by 4. 1 by 4. And I3 is 9 by 2. And this we can write 1 x square plus 3 square dx. For this we will integrate. For this integration we will use one formula. Formula is integration of 1 by x square plus a square dx is equal to 1 by a tan inverse x by a plus c. This is formula for integration. So using this formula we will integrate this. So this will be 9 by 2 into 1 by, in place of a here it is 3, into tan minus x by 3 plus c. This is, now we will add all I1, I2, I3, then we will get if I is equal to, then I is equal to I1 plus I2 plus I3. If we will add all, I1 is minus 1 by 2 log x plus 1 plus I2 is 1 by 4 x square plus 9 plus I3 is, this will be cut, 3 by 2 tan inverse x by 3 plus the answer. I hope you must have understood this solution. Today up to here, we will meet in the next session with the next question. Till then, take care. Thank you.